For the first time ever, the Hubble Space Telescope and the James Webb Space Telescope are both zeroed in on the identical interstellar intruder, 3I Atlas. It's not merely one powerhouse observatory, but our pair of premier tools scrutinizing it across visible, ultraviolet, and profound infrared wavelengths. Dual viewpoints, distinct instrument suites, a single focus. Positioned in low Earth orbit, Hubble is charting the object's coma, that expansive shroud of vapor and debris billowing from its core. Positioned a million miles distant, James Webb is probing its spectral signature, decoding the molecular traces. This marks uncharted territory. No prior extraterrestrial wanderer from outside our solar system has faced such joint scrutiny from our keenest cosmic sentinels. And there's good cause for their dual attention. Ordinarily, Hubble and Webb avoid overlapping targets. Their schedules are precious. Their objectives diverge sharply. Yet, 3I Atlas defies the norm. Leveraging its keen sight in visible and ultraviolet ranges, Hubble monitors the coma, that luminous veil of gas and dust encircling the dense heart. On July 21, 2025, it yielded the sharpest view to date, a dim, ethereal sheath spanning tens of thousands of kilometers, veiling a core just a handful of kilometers across. Such visuals allow researchers to gauge the object's outgassing rate. Projections vary from 6 to 60 kilograms per second based on particle dimensions. Imagine a vehicle's mass evaporating into the void each minute. At the same time, from its remote vantage a million miles out, the James Webb Space Telescope reveals sights beyond Hubble's reach. The elemental signature of this cosmic nomad. Through its infrared sensors, Webb has verified traces of water ice, carbon-rich particles, silicates, and intricate organic compounds, substances potentially preserved in stasis for over 7 billion years. In tandem, they deliver an unprecedented asset, a comprehensive spectral analysis of a body forged near a distant star. Its makeup, dynamism, and conduct, all captured with remarkable precision. Early merged datasets from Hubble and Webb highlighted an intriguing anomaly. Not a lone striking oddity, but a cluster of subtle traits that, collectively, defy expectations. The initial curiosity emerged from the coma. Typically, in comets, solar winds and radiation propel gases and dust sunward, crafting a tail that trails anti-sunward. 3I Atlas bucks this trend. Portions of its dust flow appear to veer sunward. Unusual, though feasible, this implies bulkier, weightier grains than standard cometary fare, ones resistant to solar pushback. An aspect of its makeup counters that pressure. Spectral insights followed suit. Webb identified anticipated water ice in a comet, alongside a tangled array of carbon-bearing molecules and silicates. Individually, none are exotic. The oddity lies in their condition, seemingly pristine, shielded from thermal and radiative assault across eons. Certain compounds might even antedate our sun by hundreds of millions of years. Hubble's visuals contribute further intrigue. The coma glows more intensely than forecasts suggested, yet the nucleus seems undersized for that vigor. This discrepancy prompts queries. Does the radiance stem from more than mere sunlight bounce? Might the exterior boast exceptional reflectivity? Or could an unfamiliar mechanism be in play? Trajectory adds yet another twist. Though retrograde, counter to planetary orbits, it's merely 5 degrees askew from the ecliptic. That's atypical. Interstellar interlopers usually arrive at sharp inclines, befitting haphazard galactic drift, but 3I Atlas aligns nearly flush with our worlds, as though navigating the identical pathway we aim probes at the outer realms. Skeptics chalk it up to luck. Proponents cite Avi Loeb's contention that the flyby order, Venus, Mars, Jupiter, boasts just a 1 in 20,000 probability under random odds. Such a figure doesn't confirm design, yet it sparks inquiry. Are the aberrant tail direction, the immaculate substances, the vivid yet compact core, and the uncannily aligned route mere coincidences? Possibly. Or perhaps they signal traces of an unseen phenomenon, be it a novel natural dynamic or artificial contrivance. Currently, the Hubble and Webb crews continue gathering and refining observations. But one certainty emerges. 3I Atlas deviates from typical cometary norms. Each datum uncovers fresh puzzles. Each resolution spawns doubles. And the window for resolution is closing fast. Quite literally. The Hubble and Webb squads lack time on their side. 3EI Atlas hurtles along at nearly 60 kilometers per second, and within weeks, it will slip sunward from terrestrial sight lines. Ground-based scopes face total occlusion. Hubble, circling our planet, will confront overwhelming solar glare. Even Webb, stationed well past the lunar orbit. The probe will need to navigate risky orientation constraints to prevent harm to its instruments. That period of darkness will strike right at its perihelion, the nearest swing by the sun, precisely when its outbursts are expected to intensify the most. As solar warmth seeps through the surface, concealed frosts might vaporize explosively, hurling out pristine debris from its core, with each surge potentially revealing minerals undisturbed since before our sun ignited. Yet we could miss witnessing it all. It's an astronomical riddle. The peak of discovery coincides with total obscurity. Still, other observers orbit within the solar system, not fixed on 3I/Atlas, but near enough to adjust their gaze. The European Space Agency's JUICE mission, headed to Jupiter's frozen satellites, will come within a mere 0.3 astronomical units of the comet over portions of this time frame. NASA's Psyche mission, en route to a metallic asteroid, will likewise skim by at a similar proximity. From such ranges, a basic imager could snag views far beyond Earth's capabilities. But here's the hitch. Altering these trajectories demands dipping into fuel stocks reserved for their core objectives, overhauling flight paths, and persuading control teams to hazard a detour for something deemed harmless by official accounts. Out in the void, each gram of fuel spells endurance. Any deviation bets against the odds. And then there's the boldest proposal in play, deploying NASA's Juno orbiter, now circling Jupiter, for a close pass by 3I/Atlas come early 2026. The scheme, put forward by Avi Lobo and his team, is audacious. It'd involve Juno whipping around Jupiter for a huge velocity kick, the sort that might position it to intercept the comet as it departs the inner solar system. The calculations check out on simulations. In practice, though, Juno's primary thruster is faulty, and its leftover propellant may fall short for that exacting adjustment. Some experts hail it as a smart repurposing of assets already in place. Detractors dismiss it as wild speculation. Yet all concur on this. Success would yield humanity's inaugural intimate glimpse of an extrasolar wanderer. That's fueling the urgency. For this isn't merely another icy body drifting past. It's a fragment from an alien stellar realm, a harbinger from realms beyond our grasp. Should it hold unfamiliar enigmas, this could be our sole window to decode them. Before long, it'll fade into the distance. Its envelope will dull. Its light signature will blend into the cosmic static, and it'll dwindle to a faint speck, eluding even the finest observatories worldwide. Once lost, pursuit becomes impossible. No do-overs. It's a dash against orbital dynamics, against solar glare, against the cosmos's silent apathy. Time presses on. In the near future, 3I/Atlas will exit our view. It'll arc behind the sun, lost in its brilliance. Upon return, it'll be outbound already, dimmer, swifter, evading our most advanced detectors. A fleeting guest from distant stars, gliding mutely through our domain before vanishing. The observations from Hubble and Webb unfolding now, the snapshots, the analyses, the measurements, will stand as our enduring archive through the ages. Each data point, every anomaly in the readings, will fuel studies for generations. And still, full clarity might elude us. Perhaps it's precisely as the skeptics claim, a straightforward comet. No frills, no extras. Old as time, from afar, sure, but ultimately frozen rubble obeying gravity and fortune. Or perhaps, woven into the play of radiance and darkness, lies an insight we're not yet equipped to spot. A nuance too faint for casual scrutiny. A clue embedded in the grains. A path that defies pure chance from the start. If so, recognition may dawn slowly, years or ages from now, when an overlooked quirk rewrites our knowledge. By then, revisiting won't be an option. Out there, playback doesn't exist. The notion inspires awe and a touch of dread. A shard from elsewhere hovers tantalizingly near, and we're scrutinizing it with our full arsenal, not only to decode the object, but to reflect on our place. Someday, another cosmic drifter will arrive. Be it soon or ages hence, it's inevitable. And we'll recall this era, when our premier telescopes united their vision, not on remote galaxies, but on one tiny intruder in our stellar backyard. To witness the next such arrival, sign up. Send your beacon. The heavens hold no voids. They never did. And at last, we're starting to perceive their fullness.